Welcome, ladies and gentlemen. Today we have for you problem 5.66, and obviously you can tell by our very descriptive drawing we have a jet ski here. Within this jet ski we're going to look at the concept that we've been studying, conservation of linear momentum. We have first the inflow into the jet ski, which is coming in at a 30-degree angle, and then once going through the system leaves with the outflow of V2. As you can see here, this is our control system, which is outlined with the shape here. To start off this problem, we're going to first describe the forces and then the fluxes, both in the I direction in this case for this problem. We have Rx, which we've labeled here, and it's given in the problem statement as 300 pounds. And then we come over to our fluxes in the I direction. We have your rho times V1, and then using your basic trigonometry, have it coming in at cosine of 30 degrees. And that has a negative Q value because it is that inflow in this problem. And then you also have a flux of your V2 value, which is, so you're going to have rho times V2, and then in this case a positive Q value since it's your outflow. We come down here and we want to set the forces and fluxes equal to each other. So we have your Rx on the left side of the equation set equal to your your second flux here, and then you subtract our other flux value. So we have this equation, and then we introduce the conservation of mass in this point in the problem, where m dot is equal to your rho q, which just helps us simplify this equation considerably for us. So we have rewritten it as your Rx is equal to your m dot V2 minus the m dot V1 cosine of 30. And welcome back for part 2. Okay, so before we were introducing conservation of mass, and from that we were able to substitute in m dot for our rho AV in this case. So we have this equation, as you can see. Then we'll take it one more step and we'll simplify it by pulling out the m dots, which kind of just clears it up for everybody. And then what we're going to do is we're going to, at this point, attempt to solve for our velocity 1, the inflow. So we're going to come back and use that same relationship we had before and introduce the rho AV once more, plug that back into the equation. And then we also know that your rho of water times your A1 V1 is always equal to your rho of water times A2 V2. So we can manipulate that relationship there so that we can relate V2 to the areas of A1 and A2 and also V1, as we can tell right here. So we're going to take this equation we had before. We're going to substitute in our V2 value up here. So we get this equation where we have, instead of V2, we have A1 over A2 times your value of V1. Alright, now we're in the home stretch. We'll try to finish up here quickly so we don't put you to sleep. But we have just introduced our relationship between the areas of our inflow and outflow as well as our velocities of the inflow and outflow. So in that case we had V2, which was equal to A1 over A2 times V1. So we had put that into the equation for our V2 value, and that's where we finished off in the last segment. We'll now simplify it one more step by bringing the V1 values out. So we have V1 squared in front of our equation, and now we're ready to solve for our answer, which is actually, we didn't do a real good job of discussing, is in this equation we're solving for the flow rate that's needed through the jet ski to create that thrust, the Rx of 300 pounds. So now we're ready to solve. We have our Rx value of 300 pounds, which was given, rho of water, which could be looked up in the back of our books as 1.94 slugs per feet cubed. We multiply that by the area of the inflow, which was given as 25 inches squared. We've converted that into feet squared. We have our V1 squared value, which is what we'll solve for initially. And then we also have our A1 over A2, which is just a ratio, so we can keep it in the original 25 inches and 3.5 inches given in the problem statement, and then finally minus your cosine of 30 degrees. Solving for V1, we get 22.6 feet per second. And then we can finally go ahead and solve for Q, which is, as we know, the value of your V times your A. And in this case, it's 22.6 feet per second times 25 over 144 feet squared. Solving for that finally gives us a value of 3.94 feet cubed per second. So we're saying that that flow rate through the jet ski needs to be 3.94 feet cubed per second to produce a thrust of 300 pounds in the RX direction.